So, hello everyone. We are going to start this conversation related to how to approach current affairs as far as geography is concerned. So, see, in geography, you might see current affairs daily. In geography also, in environment also, in science and tech also. These are some of the areas which are basically covered in multiple aspects. Why there is this kind of um, aspect? Let us discuss first. For example, if you see geography, then what all aspect is needed? First of all, we have to see physical geography aspect. So you might see questions from earthquakes, tsunami, landslide, cyclones. For example, cyclone Monta is coming. So cyclone, cloud burst event like this. These are related to physical geography. Now, these are majorly hydrological and climatic phenomenon. So they are quite dynamic. This is a dynamic topic. Whereas if we see the diastrophic phenomenon, which are slow phenomenons like plate movement or these kind of things, mountain building, plate movement, these are comparatively slow phenomenon. So we hardly get any news related to these. So usually in geography, in physical geography, the news that we see in current affairs or the topics that we see in current affairs, they are majorly from the areas which we usually call as disaster. Okay. Apart from this, we see lots of news from Indian geography aspect because lots of places for different reasons might remain in news. For example, a disaster related event has happened or some event is going to be organized by government. So in those aspects there might be places. These places might be in news. So we often see in current affairs materials places in news related to world and Indian geography, right? But then another aspect is there, that is human geography, which we mostly miss because sometimes we don't understand that human geography aspect is whether it is related to economy or whether it is related to geography or whether it is related to science and tech aspect, because there is lot of interdependence among these subjects. Because if you see geography, then in geography you will read about economic geography as well, political geography as well, environmental geography as well. So geography has taken lots of things from different subjects. That's why in current affairs we see lots of news related to geography, or we in any news we can pick the geographical aspect related to that particular news. Okay. So in human geography, if we add economic geography, then population related news, urbanization related news, settlement related news, we might get lots of news, lots of case study if we see these areas. So these topics are important for both prelims as well as mains. Okay. For example, in mains, there were in prelims, there were 5 to 6 questions from places in news in the world. They were in news because of different reasons. If we see the African countries, they were in news because of coup, the military coup that has happened in Mali, Chad, Somalia. All for all those reasons, they were in news. So UPSC picked those places and asked why these places were in news. So You might say that this is a question of international relation, but that is a question of geography as well. So international relation without geography is not possible, or geography without international relation is incomplete. So that is how we have to look any news related to geography. We need to cover the geographical angle, the political angle, the social angle, economic angle from different angles. We have to look into the topic, and then we need to cover these areas. So on this premise, let us start the today's lecture. That is a demo lecture on current affairs that was there in 2025. And today's topic is Indian monsoon of 2025 and earthquakes in 2025. So I asked you that you all that you need to cover the basic aspect, because once you are thorough with the static part, then current affairs becomes easier. Although we will try to cover those aspects in this class as well, because there is lot of interlinkages if we see the current affairs news. So first of all, let us start with the Indian monsoon. So if we see Indian monsoon, how much rain does Indian monsoon covers? That is the first aspect that we need to see. If we see the average annual rainfall of India, then average annual rainfall is around 87 centimeter. If we see the long period average as far as monsoon season is concerned, 87 centimeter is basically the overall rainfall that is being received since 1971 till 2020. But does India receive rainfall only during the month of monsoons, those 4 months only from June to September or October? No. India receives rainfall in different months as well, which are not monsoonal rainfall. So around 80% of rainfall in India is because of monsoon. 75 to 80%, we can roughly say that it is associated with monsoon. Rest 20% of the rainfall is related to various other reasons. They can be convectional rainfall in different places. For example, in Andaman and Nicobar Island, there is rainfall. So these kind of scenarios we can see if we look into the Indian monsoon aspect. So first of all, if we talk about the Indian monsoon, then we know the phenomenon that how Indian monsoon occurs. So there are basically, if you look at the static part, there are two theories related to it. First is the thermal theory, which most of the geographers have discarded this theory. Why? The reason was that this theory was kind of noise, because it said that the way land breeze and sea breeze occurs, in similar manner there is monsoon. A low pressure area is being developed at the northern India part, and because of that, if we draw the map of India, so here we can say that as far as this theory is concerned, here we can say that there was development of low pressure area, and because of this low pressure area, the monsoonal breeze used to get pulled towards this region from the comparatively high pressure area. So this was the thermal theory. But most of the geographers discarded this, and now we consider the dynamic theory. And as far as dynamic theory is concerned, lots of factors, multiple factors basically impact Indian monsoons. So, and there is a statement, there is a saying that an Indian monsoon, uh, even a butterfly in a room in London can impact Indian monsoon. These kind of sayings are there as far as Indian monsoon is concerned. So why this saying is there? Because we know that Indian monsoon is dynamic in nature. Multiple factors impact Indian monsoon. That's why it is a subject which is tough to predict. So when this year IMD predicted that there will be above normal monsoon, they were quite correct. To some extent, they were correct, but they were not able to predict how much amount of rainfall is going to happen in 2025. Okay, we will see the various schemes that is going on. We will see Mission Mosam in future, which is related to the prediction of Indian monsoon only, or the weather system, overall weather system that is there in India, that is related to the prediction game. But here, the monsoonal anticipation, if we look at into this aspect, the monsoon anticipation was done by IMD, and they said that there will be above normal monsoon. Now, for that, what is normal monsoon? First of all, we need to see what is normal monsoon. So, we basically classified the long period average from 1971 till 2020. This is a 50-year period, and on this basis, we said that the average rainfall that is being received in India is 1887 centimeter, or which is a round figure. Accurate figure is 86.8 mm. Okay, or 868 mm, 86.8 centimeter is the accurate figure. But if we talk about normal monsoon, then what is normal monsoon? Normal monsoon is basically slight deviation. If there is slight deviation from the long period average, that is plus minus 4%. So 96 to 104% of LPA is considered as normal monsoon year. If we talk about the below normal, then 90 to 96% of long period average is considered as below normal. And if we talk about above normal, then 104 to 110% of LPA long period average is basically considered as above normal monsoon. So IMD said that this year there will be above normal monsoon, but they didn't predict how much rainfall will be received by which all area. For example, how much rainfall Kerala is receiving or will receive, how much rainfall Punjab will receive, how much rainfall Himachal Pradesh will receive. That was not clear at the time of prediction. Okay, at the during the month of April. So, if we talk about other aspects that is related to prediction, then we can say that roughly we can say that if less than 90% rainfall is happening, then we can say that it is going to be a deficient year. If more than 110% rainfall is happening, then we can say that there is going to be an excess rainfall. So these are the data which you can basically write as far as the monsoon is concerned. Okay. But this year, what happened? They predicted that the monsoon will arrive by the end of May. That is the usual date of monsoon, by 25th of May, or either by 25th of May or just a second, just a second. यस, यस सर, बढ़िया सर. मैं तो Am I audible now? Oh, just a second. Yes, this might be good now. Am I audible? Okay. Okay, so let us continue. So, this year, what happened? The early monsoon happened. Uh, so, what was the date? When was the arrival of monsoon? So, onset of monsoon usually occurs in and around 20th of May in Andaman and Nicobar Island, and by 1st June in Kerala. This is the usual date. This is the usual date when monsoon comes. If we see this image, then we can see that this is the iso height. Basically, iso height is line joining the same rainfall. Okay, so these are the iso heights when arrival of southwest monsoon happens. So it first hit the Andaman and Nicobar Island and then hit the Kerala coast. So on this year, the monsoon arrived on May 13th. Okay, and this was quite early. This was 1 week or 10 days prior to the estimated days. You can consider that when there is early monsoon, then there will be more rainfall. There will be more rainfall than what is the average, what is the long period average. So that happened this year. And what caused an early monsoon? That is the major aspect that we need to see. So there was multiple reason related to the early monsoon. First was Maiden Julian oscillation, then Mascarenas high, Somali jet stream, and low pressure in North India as well was the reason. So this is the aspect which I was talking earlier, that the dynamic nature of monsoon is basically responsible for the early onset also. If we see the atmospheric and oceanic condition that is there as far as Indian monsoon is concerned, then multiple things impact Indian monsoon. For example, the polar jet stream also impact Indian monsoon. You might have heard about this year's deluge, basically why such nature rainfall happened in Himachal Pradesh, why there was flood in Punjab. There are multiple articles related to it. You might have seen various videos in Instagram or any social media, whichever you use. You might have seen multiple videos. So why that has happened? So there was one article related to it, that western disturbance came early this year. So why Western disturbance came early this year? This is the main question. Because usually, what is the date of Western disturbance? You might have read about the Western disturbance. Yes, somebody might answer. Yeah. Why there was Western disturbance, early Western disturbance this year? Or what is disturbance? What is the usual date of onset of Western disturbance? Usually, you might have heard that Western disturbance occurs during the winter months in India. Okay. So yeah, Feb to March, correct. So during the Feb to March period, we see Western disturbance. But this year, during the month of July, August, there was Western disturbance. What was the reason? The reason was the warming up of Arctic Ocean. So because Arctic Ocean, which we usually say that it is Arctic amplification. Okay. So the warming up of Arctic Ocean led to the rising temperature of air above it, because of which the polar jet stream became weak. And that polar jet stream, after it became weak, it started meandering, and that led to southward shift of the whole trough that is there. Whatever frontal system we see, whole trough shifted southwards. And because of that, the western disturbance, which usually comes during the months of Feb to March, or Jan to Feb, That came early because of the southward shift of these polar jet streams. So polar jet stream shifted south. Along with that, subtropical westerly jet stream shifted south. Along with that, the western disturbance also shifted southward. So that was the reason that there was collision of basically the southwest monsoonal wind and the uh, western disturbance, which led to more rainfall. Along with that, the maiden Julian oscillation. You might have heard about this phenomenon that the maiden Julian oscillation happens in the equatorial to tropical belt region, and there is an oscillating period of 30 to 60 to 90 days. Okay, and there are two phases in maiden Julian oscillation. One is enhanced rainfall phase, and another is suppressed rainfall phase. So what happens in enhanced rainfall phase? That if the onset of monsoon, if we again look at this diagram, if suppose there is onset of monsoon in this particular area, if onset is happening, suppose this is the onset of monsoon. Okay, from here it get bifurcated. So during the time period of onset, if there is enhanced rainfall phase in this region, suppose in this region there is enhanced rainfall phase, so there will be cumulatively more rainfall in this particular area, more rainfall. Okay, so this happened along with maiden Julian oscillation. Along with this, what happened? The Mascarenhas high, the high pressure area that basically pushes the monsoonal wind towards the uh, Indian subcontinent, that became strong. Then the Somali jet stream also helps in steering of Indian monsoon, that also became strong. And the low pressure in northern India was intense. Why it was intense? Because the summer was intense in India. Because of summer, the low pressure was intense, and that basically pulled. So if we look into the thermal theory, then thermal theory suggests that monsoon happens because of development of low pressure area only. It doesn't talk about any other factor. But here we see that lot of factors basically impact the Indian monsoon. For example, maiden Julian oscillation, Mascarenhas high, Somali jet stream, low pressure in northern India, polar jet stream, western disturbance. Along with that, La Nina, El Nino also impact Indian monsoon. You might have read about it. Indian Ocean dipole impact Indian monsoon. These are basically teleconnections. We call them teleconnections because some have indirect impact as far as Indian monsoon is concerned. So cumulatively, we call them teleconnections. So if we talk about, let's say, suppose there is another phenomenon, Pacific decadal oscillation. Pacific decadal oscillation also has impact on Indian monsoon, but this year there was not impact of either Pacific decadal oscillation or El Nino or La Nina because IMD clarified that this year is going to be normal year. And you might have read that El Nino indirectly impacts the Indian monsoon. And during the El Nino year, we face deluge as far as Indian monsoon is concerned because there is drought-like condition during El Nino year in Indian monsoon. That is a separate topic. We will deal with it separately when we look into uh, this teleconnection phenomena. We will cover it separately. Okay. So here what happened during El Nino year, if we look into the last 30, 30 to 50 years El Nino, 7, 8 El Nino occurred in last 50 years. So in those period, 3 out of 8 El Ninos caused drought in India. Whereas during the rest of the 5 El Nino year, there was hardly any impact on Indian monsoon. So yes, these events basically impact Indian monsoon, but not that directly. But this year, because of intense heating, so the if we have to prioritize this point, then this point will come first. That because of intense heating of northern India, low pressure area developed, extremely low pressure area developed, which led to the pulling of the southwest monsoon. Apart from that, these other factors like Somali jet stream, Mascarenas high, Maiden Julian oscillation, they also impacted the Indian monsoon. Okay, so how much rain did we receive? We received 8% more monsoonal rains as compared to the long period average. So there was 108% of long period average rainfall this year as far as 2025 is concerned. So this was in extreme category, extreme above normal category also, or we can say that India records extreme rainfall. Why we call it extreme rainfall? Why the meteorologists are saying that northern India has received more rainfall as compared to southern India, because the rainfall was not evenly distributed. Some of the areas received more rainfall. For example, the Punjab, Haryana, Western UP, and Delhi region, it received more rainfall, the northern India section. Whereas the southern Indian states like Kerala, Tamil Nadu had received comparatively less rainfall. There was a deficit of around 36% as far as Wayanad is concerned. Wayanad receives a lot of rainfall. You might have seen the news as far as Wayanad landslide is concerned. Recently, it happened. And you might have heard about two committees as well that is linked to environment. Let me write that: Kasturi Rangan Committee and Gadgil Committee, right? So, and they both highlighted that Wayanad is vulnerable as far as landslides are concerned. So Wayanad landslide happened, but still the monsoon was comparatively less, or there was a deficit of rainfall as far as the Kerala region is Kerala as a state is concerned, and particularly Wayanad received 36%. Overall, Kerala received around 18 to 20% less rainfall than what was expected this year. Okay, so as far as rainfall is concerned, as far as monsoon is concerned, this was the case related to Indian monsoon of 2025. Now, what happened because of this nature of monsoon? First of all, we saw the floods. We saw the Punjab floods. We saw the Himachal Pradesh floods. We saw the cloudburst event. Okay, lot of thing. We saw the landslides. Lot of thing we saw. Different types of disasters we saw as far as this particular monsoon year is concerned. So, how much rain does Himachal Pradesh and Punjab receive? The average rainfall is around 270 centimeter, 270 as far as Himachal Pradesh is concerned. But this year, Himachal Pradesh received 431 of rainfall, which is 68% more than normal. Okay. And as far as Punjab is concerned, so Punjab received 254 in the month of August only. We are talking about the month of August only, which is 74% more than normal. So definitely they received more than 50% of rainfall. And if we see the excess rainfall, then it was decided on the basis of the data that was there since past 30 years. So this was the highest rainfall that was received by Himachal Pradesh and Punjab. Now, what happened when Himachal Pradesh received this amount of rainfall? The rivers that were there, that were coming from Himachal Pradesh to Punjab, they swelled, and because of those swelling of rivers, the Punjab received this much amount of uh, uh, rainfall. So 11 out of 23 districts in Punjab were adversely impacted by the floods. You might have seen the various images again related to the floods of Punjab, because in Himachal Pradesh there was comparatively less flood, but in Punjab there was extreme flooding as far as this year's monsoon is concerned. And the reason are multiple. Can we say that the only reason for Punjab flood is the amount of rainfall it received, which is above 50% or above 70% than the normal? Can we say that? Yes. Anybody? Is it the only reason, or there are multiple reasons? We can say you have to think about the multiple reasons. The reasons that we can say is, look, I just want to say one thing, that let us make this session comparatively interactive. Okay. So if you answer, you can unmute as well. If you want, you can unmute yourself, and we can make this session comparatively interactive so that I can ask some questions, because otherwise it will be like one-sided event. Okay? So it's better to have a conversation like uh, class, because then your doubt will also get clear. Whatever doubts you have related to what is happening as far as Indian monsoon is concerned, or whatever uh, things are concerned related to Indian monsoon. So my question is this again, that why Punjab received when Punjab received this amount of rainfall, it the is this the only reason as far as Punjab flooding is concerned, or there can be other reasons as well? Are there other reasons? Definitely, there are other reasons. If we see the reasons like the river morphology, and I am expecting if someone has geography optional, there might be climate change. Okay, climate change is a very, very, very broad term. Okay, because if we simply write climate change, that climate change is the reason why that we are receiving this much amount of rainfall, then we will not be able to elaborate it. Okay, we have to look at all these aspects, that why monsoon is becoming more dynamic, why, what is the impact of polar jet stream, what is the impact of western disturbance. All these things are linked to climate change, right? Why Arctic amplification is impacting Indian monsoon, we can also link these things to Indian monsoon. Okay, if we have to basically make a flow chart related to what all factors are impacting Indian monsoon, then we can write climate change, but under climate change, we can write about Arctic amplification, then southward shifting of polar jet stream, the untimely onset of western disturbance, that during the months of summer only, or during the season of monsoon only, the western disturbance is impacting India, is coming to India. So these factors are basically linked to climate change. Apart from climate change, there are multiple human factors as well. This is not only linked to monsoon. The human factors are the encroachment in the flood banks. You might have seen the videos that various highways have been built in the flood banks of rivers. So basically, river retook its course. If we talk about the floods of Himachal Pradesh and Punjab, there was a very famous dhaba near Punjab Himachal Pradesh highway that basically swept uh, during the floods. Why that happened? Because they built that the permission was given to this particular dhaba by the authorities of that particular region. There was multiple reports related to it, that people of Himachal Pradesh were saying that authorities are responsible as far as floods are concerned, because along the course of the river there shouldn't be any encroachment, but because of that encroachment, the channel or river morphology, we can say, that changed. We look into the channel morphology, so the course of the river changed, and along with the course of the river, there was siltation also as far as the rivers was concerned. Look, when IMD said that, or IMD predicted that there is going to be an above normal monsoon year this year. Okay, so what kind of preparation should have been there? That is the question we need to ask. Okay, you need to again and again think that what all preparations were there as far as authorities are concerned. Okay, so human encroachment is also a major reason, and channel river morphology is another reason as far as the monsoon is concerned. Now, if we see the other aspect related to the floods that has happened, it was linked to monsoon, it was linked to human impact. Along with that, it was linked to cloudburst as well. Various cloudburst event happened. And does anybody know the definition of cloudburst? How IMD defines the cloudburst as far as India is concerned? Yes. As far as IMD is concerned, IMD says that if 10 centimeter and above rainfall happens in 1 hour in 10 square kilometer area, it will be considered as cloudburst. So cloudburst also occurred in Himachal Pradesh region, and various cloudbursts occurred in Himachal Pradesh, Uttarakhand, which led to flooding in those particular area. So The flooding this year, the way we saw the flooding, you must have seen the Dharali flooding of Uttarakhand. That occurred because of the cloudburst event. Okay, so cloudburst, okay, it is difficult to predict cloudburst, no doubt. We can say that it is an extremely localized phenomenon, and we will not be able to basically pinpoint where cloudburst event might happen. But what is our preparation? Our question is from the authorities is this, that you need to see the slope as far as a particular region is concerned. We need to do the slope analysis. Only then we can allow the construction of infrastructure as far as these slopes are concerned, because otherwise vulnerabilities will be there. If we do deforestation, if we don't plant trees, then there will be, if we don't plant trees along the slopes, if we don't make this kind of retention walls, there will be floods, landslides, as well as cloudburst events. So we need to be prepared. We need to see that in Himachal Pradesh, lot of thing has happened. A lot of cloudburst event has happened. Lot of landslide has happened. Lot of not only in Himachal Pradesh, in Uttarakhand as well. In Sikkim, it is happening. In Sikkim, GLOF is happening. Now you can say that this glacial lake outburst flood is linked to climate change, but why there is such linkage, and what is our preparation? That is the question we need to ask. Okay. Now, how it is impacting the other aspect, how monsoon is impacting Indian agriculture. Now, when you study agriculture, you might have studied the agriculture in both economics as well as geography. When we study Indian agriculture, we say that Indian agriculture is gamble upon Indian monsoon. Why we say that? You, you need to ask this question, why we say again and again that Indian agriculture is gamble upon Indian monsoon. Because if we see the agriculture net cultivable area or gross cultivable area, then around 50% of it is still dependent upon monsoon. Why? Because only around 50 to 55% of the net sown area is irrigated, or there is irrigation facility. Definitely, there are states in Punjab, in northern India like Punjab, Haryana, UP, where you can see a lot of irrigation facility, because in Punjab there is 90 of all the total cultivable area, 98% of the fields are irrigated. So hardly they are dependent upon monsoon. In Haryana, it is 85%. In UP, 76% of the fields are irrigated. So hardly there is any dependence as far as monsoon is concerned. But in areas like the eastern India, or the BSHW area we call in Köppen classification, that is the semi-arid region of the central India, those are dependent upon monsoon. And this year, what happened, because of above average rainfall, the Kharif crop total cultivated area has increased. It has increased to 111 million hectares. That is plus 1.5 million hectares. So around 15 lakh hectare increase is there as far as Kharif crop cultivation is concerned. That has increased. As far as rice cultivation is concerned, that has increased by 8 lakh hectares, or 0.8 million hectares increase is there, because the rice cultivation during the Kharif season was 43.8 million hectare. And you know very well that rice is a water intensive crop, and it needs a flood kind of irrigation. Flooded irrigation is needed for that. And that's why wherever we receive more rainfall, or wherever the impact of monsoon is more, there are rice growing areas. So that has increased in this particular region. So this article particularly talks about the changing nature of the agriculture as far as the monsoon season is concerned. Now you might be thinking that more rainfall is good. Okay, because our agriculture system is dependent upon Indian monsoon, but that is not always true. We earlier, the policymakers or the bureaucrats, they usually uh, used to think that more rainfall is good as far as agriculture is concerned, because our economy also used to be dependent upon agriculture. At present also, it has huge share, 18%, 17 to 18% of GDP is agricultural GDP. Okay, and that and 50% of agricultural GDP is dependent upon monsoon. So definitely there was impact as far as monsoon is concerned, but not more rainfall is not always good. Why it is not always good? Because areas like Punjab are impacted by flood, where lot of agriculture, where majority of the agriculture, as far as Kharif and Rabi season happens, that got impacted in this particular because of this particular more rainfall. Okay, and if there is no particular rainwater harvesting system, then this will there will be ill impact as far as monsoon is concerned. Now, if we look into another aspect, this all this aspect was related to Indian monsoon. Okay, and it was related to southwest monsoon basically. When we talk about the onset of monsoon, we basically talk about southwest monsoon. We will look into these things that how monsoon happens. We will quickly revise after this particular topic, the whole monsoon topic. But if we look into this thing, that what is the impact of southwest monsoon, then we saw multiple reasons. What is the impact of southwest monsoon on economy? We saw multiple issues related to agriculture. What is the impact of disaster that is happening because of monsoon? We saw landslide, we saw floods, we saw cloudburst, and that has indirectly impacted the infrastructure. Not indirectly, that has directly impacted the infrastructure as far as uh, road infrastructure is concerned, bridge infrastructure is concerned. Because of flooding, lots of fields were flooded, lots of standing crops were lost because of the huge flood that has happened in Punjab and Himachal Pradesh. Okay. Even if you see, there is one district, Mandi district in Himachal Pradesh, it hardly used to get flood. But now, since last 4 to 5 years, this district is getting flooded on regular basis because of heavy rainfall. So it is impacting the biodiversity, it is impacting the environment, it is impacting the agriculture of Mandi district. And Mandi district, there is uh, cultivation of or horticulture practices are there as far as Mandi is concerned. Mandi is also famous for apple cultivation, and lots of it is famous for tomato cultivation. So lot of rotting of these fruits and vegetables happened because of the early monsoon and more monsoon. But now what is happening? Now monsoon is retreating. Okay, but that retreat is also early. Okay, so along with the monsoon, there the southwest monsoon that is there in the southern section, the retreating monsoon is also impacting the southern section. So that's why this article particularly talks about the early northeast monsoon, that is the retreating monsoon. This creates triple whammy in southern India. Now, what are the triple whammy? What triple whammy is there as far as southern India is concerned? We have to see the state of Kerala and Tamil Nadu as far as this particular topic is concerned. Because first of all, you might have heard in last 5 to 6 years, there used to be continuous flooding, urban flooding, especially in Chennai. Chennai floods are famous. Why Chennai floods happens? It is related to both northeast monsoon. It is related to cyclogenesis as well, if we talk about the tropical cyclone. But at the same time, the reason for this is again uh, ill infrastructural development. Because what we have created the concrete jungles as far as Chennai is concerned. Because water logging happens, clogging happens, and because of that, flooding happens. The water doesn't get recharged when because of this concrete infrastructures that are there. As far as if we particularly talk about Chennai, and in majority of the cities in southern India, we can see that the infrastructure development is particularly poor. If we talk about the rainwater harvesting aspect, that is not at place, and that's why we see lots of incidents of flooding. You might have heard about the Gurgaon floods as well. Every year it happens. Why it happens? Because there is no place provided by the administration or the developers for the drainage of the flood waters. So definitely it will happen. So this is the first reason as far as triple whammy is concerned. The second reason is agriculture sector's vulnerability. This is what we were looking that more rainfall is not always good as far as agriculture is concerned. because 20 to 30% of the crops they get impacted because of more rainfall, if there is more than average rainfall. Okay, and that is happening at regular basis. Now the because of the climate change, somebody was saying, I guess, the impact of climate change. John was saying that the impact of climate change is there as far as this particular monsoon is concerned. So, because of climate change, the monsoon is becoming more erratic. It is becoming more, it is basically impacting each and every area. So, agriculture sector is also vulnerable because we will not be able to grow crop timely. Because we have a particular time as far as sowing season is concerned, we have a particular time period as far as harvesting season is concerned. And if the monsoon becomes, if the onset of monsoon becomes early, then definitely it will impact just at the time of harvest. If suppose northeast monsoon arrives, then what will happen? Crop will get lost, crop will rot. So that is how the vulnerability of agricultural sector is dependent upon the Indian monsoon, the amount of rainfall that is happening. Another aspect is the increased water table. Now, someone will say that, sir, you were saying that rainwater harvesting is not happening. If rainwater harvesting is happening, then water table is also increasing. So this might be a good thing. Why there would be a problem if there is increase in water table? There is a problem because our structural engineering is such that we have not created the design in a way that it can stand the uh, flood waters. And we are poor as far as disaster risk reduction is concerned. We do not follow Sendai framework holistically till now. If we have to criticize as far as criticism, we talk about constructive criticism. If we have to do that, then we can say that disaster risk reduction is not happening because we are not building disaster resilient infrastructures. Okay. And since we are not building disaster resilient infrastructure, water table is increasing, because of which structural damage is happening as far as various buildings, bridges, roads are concerned. And this we have seen in case of Punjab, and this we have seen in case of Himachal Pradesh, Uttarakhand also. A whole section of the highway was swept away by the floods. Why that is happening? Because of the increased water table, there was weakening of the particular basement, and because of this, the whole section got swept away. So this kind of triple whammy is being created because of the monsoon. So is monsoon clear? Monsoon related events clear so far? Because now we will see the aspect as far as various. Now let us look into the basic aspect of Indian monsoon. Okay, let us quickly discuss how monsoon arrives. You might be knowing about this particular, you might have read also. Triple whammy. Okay, triple whammy is basically triple problem is there. Triple problem is going to happen as far as southern Indian state is concerned. Okay, so these are the problems. This urban flooding is the first problem. Second problem is the agricultural sector vulnerability. And third is the increased water table that will lead to structural damage. So structural damage is also a problem. And that is happening because of the collision of or early onset of northeast monsoon. Now, you might have seen the cyclone Monta news recently that is going to happen in Andhra Pradesh and Odisha, right? At the same time, retreating monsoon is coming. So both these will increase the amount of water in that particular region. So in Andhra Pradesh also this will happen. In Tamil Nadu also this will happen. In Kerala also this will happen. So increased amount of rainfall as far as this particular area is concerned, that will lead to triple whammy, triple problem in southern India. So this is triple whammy. Okay. Now let us look into the uh, Indian monsoon basic aspect. If we see the Indian monsoon, if you see the Indian monsoons, then we know that Indian monsoon onset is basically on the around the 1st of June, 25th May to 1st of June, as far as Kerala coast is concerned. And then it gets bifurcated into two branches, right? One is Arabian Sea branch, and another is Bay of Bengal branch. And then this Arabian Sea branch, this continuously hits the Western Ghats and leads to heavy rainfall. Why there is a turn as far as Arabian Sea branch is concerned? Why it is turning on the right direction? If we see this right direction, why there is a turning in right direction? You might have guessed it right. The reason is Coriolis force. Okay, because in northern hemisphere, anything moving in any direction will turn towards its right because of the Coriolis force. So Coriolis force is leading to the rightward shift as far as Indian monsoon is concerned. And as far as Bay of Bengal is concerned, this is also shifting towards its right and directly hitting the Meghalaya region, Meghalayan plateau or Shillong plateau. It hits the Shillong plateau, Garo Khasi Jayantia Hills. So there is huge amount of rainfall in this particular area, and there is huge amount of rainfall in the western section of the Western Ghats. Around 400 centimeter of rainfall, 300 to 400 centimeter of rainfall happens in western section of Western Ghats and the eastern India, that is the Meghalayan region. Now this enters towards the Aravali Hills, towards the Vindhyas, towards the Satpuras, and from here it enters. If you see the Garo Khasi Jayantia hills are like this. So this monsoon enters towards the Assam plain. And since they get funneled in the gaps between the Garo Khasi and Jayantia hills, there is more rainfall because of the funneling effect. Okay. Now there is Himalaya here. If we draw like this, there is Himalaya here. Now this will enter this region. Monsoon will enter this region, and there will be rightward tilt, rightward tilt. So this is northern Himalaya section. This is Purvanchal hill complex. Here also rainfall will happen, and this there will be huge amount of rainfall in Assam plain region. But after turning, this will not be able to come back. Why? Because continuously monsoon branch, Bay of Bengal branch is coming from the gaps, so it will move towards its left. It will start moving towards the Gangetic plain. And in Gangetic, once it enters towards the Gangetic plain, this will again move towards its right, tilt towards its right, and hit the southern slope of Himalayas. And there will be huge amount of rainfall in the southern slope of Himalayas. Not in context of if we compare it with Assam plain will receive comparatively more rainfall. The Western Ghat will receive more rainfall. The Shillong Plateau will receive rainfall, but the Gangetic Plain region will receive comparatively less rainfall. But as compared to other areas, if you see this rain shadow area, as compared to these areas, they will receive significant amount of rainfall. But as we move towards the Delhi region, the rainfall starts decreasing. Why? Because there is not much amount of water to to provide moisture to the monsoonal trough. Okay, so this will decrease as we move towards the Punjab plain, towards the Delhi region, Rohilkhand region. The monsoon will start decreasing. Okay, why they are coming towards the northern section? That is what is the question. Now, prior to this, you might have read about this, that there is ITCZ, which is also termed as thermal equator, right? So there is convergence of trade winds. Now this leads to this ITCZ basically shifts north of Himalayas. Why it shifts north of Himalayas? That is again a question. It shifts north of Himalayas because of land sea differential heating of land and uh, land and sea. Since Asia has continentality along with the Eurasian part, this shift towards this shift north of Himalayas, this shift leads to uh, basically drifting of the monsoonal wind towards the Indian section, Indian subcontinent. If we draw Indian subcontinent here, so the southeast trade wind, once it crosses the equator, it becomes southwest monsoonal wind. Okay, so that is how the southwest monsoon comes here. But what happens? This ITCZ is shifting north of Himalayas because of the apparent movement of sun towards the Tropic of Cancer. And over a period of time, it will start shifting towards the southern section. So ITCZ will also shift towards the southern section. And once it starts shifting towards the south, the whole monsoonal trough will start retreating. As it starts retreating, it becomes it becomes northeast monsoonal wind. So this is how monsoon occurs as far as southwest monsoon and northeast monsoon wind is concerned. And the rainfall is not continuous. The rainfall occurs in spells. And because of climate change, again now since climate change topic has come, so because of climate change, the spells are becoming more and more we can say more and more intense, more and more erratic. Otherwise, there used to be 15 to 20% of the rainy days, but now the number of rainy days are increasing during the month of monsoon period. That is linked to climate change. So this is what is there in news as far as monsoon is concerned. Now you might be thinking, what about the predictability? We didn't predict this much as far as monsoon is concerned. IMD must have thought about something. So IMD has developed Mission Mosam. Have you heard of Mission Mosam? Yes, anybody? My question related to Mission Mosam is it is under which ministry? Yes, can anybody answer? Mission Mosam is under which ministry? Have you heard of Mission Mosam? It was launched this year only. Mission Mosam was launched in the no, not Ministry of Science, John. Ministry of Earth Sciences. It is under MOES, Ministry of Earth Sciences. So under Ministry of Earth Sciences, Mission Mosam was launched. It is a 2,000 crore rupees project, and it is for 2 year period. What will be the impact of Mission Mosam? That it will increase the predictability as far as the weather in India is concerned. And as far as weather is concerned, India has in weather aspect, monsoon is one of the most important aspects. So definitely it will increase the predictability. But how? We will incorporate use of AI as far as the Mission Mosam is concerned. Have you heard of Mosam GPT? This will help in faster computation of the data that is there. This will help in faster data dissemination as well. The number of weather forecasting stations or weather stations are going to be increased through this particular scheme. So if we receive more and more data, and if there is faster computation, then definitely we will be able to predict better as far as Indian monsoon is concerned. And once we predict Indian monsoon better, we can basically prepare different sectors that okay, this is going to be the impact of Indian monsoon. This is how you can prepare yourself for different types of disaster related to it, or because we see that infrastructure is getting impacted, agriculture is getting impacted because of the erraticness of the monsoon, because of more and more rainfall, not normal rainfall, but above normal or extreme rainfall. That is what is to be basically dealt as far as uh, Indian monsoon is concerned through Mission Mosam. Also, there is one
వాళ్ళ
interesting aspect is
పడవగానే
there that we are
మనం
going to do
వెడల్పు నెక్స్ట్ టైం
someone's
జోగ్రఫీ
mic is on, I guess. So as far as this as far as Mission Mosam is concerned, there is cloud simulation center as well. So we are going to develop the cloud simulation center, and through cloud simulation center, we can see how clouds are formed, and this can help in studying the cloud burst as well. So this is what is there as far as Indian monsoon is concerned. So holistically, if we see, we have dealt with the onset of monsoon, why there was more and more rainfall as far as this year is concerned. Lot of different factors basically impact Indian monsoon, which are considered as teleconnections. For example, the western disturbance or the polar jet stream, El Nino, La Nina, Middle Julian oscillation, Somali jet stream, Mascarenas high. All this basically impacts the Indian monsoon, right? Now let us look into the next topic. Is there any doubt related to it so far, or are we good? Some of you have joined late. So is there any doubt so far? Look, in Indian monsoon, various data is important. Various data like what is long period average, because this you have to write in answers as well. What is long period average? How much is above annual rainfall? How IMD basically predicts on what all parameters it considers as far as the prediction of Indian monsoon is concerned. This is what is required as far as Indian monsoon is concerned. Okay. Okay. How questions will be asked as far as this particular topic is concerned? Uh, Indian monsoon can be linked to multiple topics as far as mains is concerned. Indian monsoon can be linked to infrastructure. Indian monsoon can be linked to agriculture. Indian monsoon can be linked to disasters. Okay. So earlier there used to be direct questions that explain the phenomenon of Indian monsoon. What do you understand by the onset of monsoon? But now questions are becoming more and more dynamic. You might have seen the question that was there in 2023 in mains in GS paper 3, that what do you understand by Purvaya and how it impacts the Bhojpur region. Like this, there was a question in mains. So now questions related to Indian monsoon are becoming more and more content driven. Earlier, we used to prepare answer as far as onset is concerned, retreat is concerned, break of monsoon is concerned, and different pre-monsoonal showers. But now you have to link it with different aspect. For example, you need to link it with disaster. That because of more rainfall, there is disaster. But that is not the only reason. Floods are happening not only because of monsoon, but because of uh, multiple human factors, anthropogenic factors as well. So we need to link different topics as far as Indian monsoon is concerned, and there might be question related to the predictability, or how IMD basically predicts the monsoon. They have asked earlier as well. They might ask now as well because they have launched this mission Mosam. So Mission Mosam related question can be there. Indian monsoon related question can be there. It can be linked to climate change as well. So there can be different questions, different dimensions can be there, which we discussed earlier as far as this aspect is there, right? Because from Indian geography aspect, it can be asked, and from human geography aspect also, it can be asked how the more rainfall impacts the economy of different regions. That that is what we were seeing when we were seeing the triple whammy aspect, right? So these type of questions can be asked as far as this particular topic is concerned, and this is a very important topic as far as mains is concerned. Definitely, it is important from mains point of view, and in mains we need to draw a map like this. We need to provide data, few of the data which we saw in this particular slide. We need to provide the parameters that are important as far as Indian monsoon is concerned. So this is how we need to organize our answer as far as mains is concerned, and question can also be from this particular topics. Okay, is it clear, John? I think it might be clear. Shall we move to in pre topics can be uh, the question can be from Mission Mosam. I was expecting a question from Mission Mosam, but this year it was not there. But there can be questions related to what all aspects are there as far as monsoon is concerned. So questions in pre from Indian monsoon is comparatively rare. It is uh, it is more towards the uh, it is more of a mains oriented topic. Okay, if we talk about the questions related to Indian monsoon, shall we move to the next topic? So the next topic is earthquake. Okay, and again, earthquakes are related to earthquakes. Basically, you might have read about earthquakes, right? If you have read geography, then why earthquake happens, you might know there can be different types of earthquake. There can be shallow focus earthquake, there can be deep focus earthquake, there can be intermediate focus earthquake. Different reasons can be there as far as earthquake is concerned. There can be earthquake because of different types of boundaries. For example, the most prominent earthquake zone is circum-Pacific belt, or the ring of fire area, which we call as ring of fire, Pacific ring of fire. So there also earthquake and volcanic eruptions happen. Why they happen? If we look into the natural reasons, then the natural reason for earthquake is basically plate tectonics. Okay, plate interactions. Because of plate interaction, plate movement, the earthquake occurs. Okay, the sudden shock happens. There is because there is huge amount of energy that is being released because of this, right? So this year also, in lot of places, earthquake occurred. In if we say that how much earthquake happens in a year, then around 80,000 to 90,000 earthquake events occurs. But since most of them are of low magnitude, that is 3, 4, 5 magnitude earthquake in Richter scale, so we consider that those are not prominent. But the prominent ones, they become disaster. The hazard becomes disaster. Okay, so that is why the study of earthquake is important, and that is why we need to see into two different earthquakes that becomes a case study. How we need to address the disaster. That is what is required as far as this particular topic is concerned. For example, let us first look into the earthquake of Kamchatka. Now, this earthquake happened on the month of July. Okay, on 29th, 30th of July, this earthquake occurred of 8.8 magnitude as far as Kamchatka region, Kamchatka province is concerned. So this is the Kamchatka province. You can see this Kamchatka province, which is in Far East Russia, and this is circum-Pacific belt, circum-Pacific belt or ring of fire. Here, which type of boundary is present? Convergent boundary. Okay. So in convergent boundary, basically the oceanic plate is converging uh, towards the continental plate. It is subducting, which is causing more and more earthquake events. This is quite dynamic region from earthquake and volcano from both point of view, and earthquake induced tsunami as well. Okay, so this region is quite prominent. You see, there was question related to tsunami, and the reason for tsunami was not this particular earthquake. The reason, what was the reason for tsunami? Yes, anybody? What was the reason for the question from tsunami in this year's main? Can anybody tell? Then we can predict what kind of questions can be asked. Yes, John. John and leading star. The reason for this year's tsunami was okay. This year question from tsunami was we basically saw the 20-year anniversary of 2004 tsunami, which came on 26th of December 2004, and this caused huge destruction and loss of life as far as Indian subcontinent is concerned, and the uh, Southeast Asian countries are concerned. So because of that 20-year anniversary, there were a lot of articles on 26th of December this year, 2024. So that was the reason, because the articles were related to the disaster preparedness. Okay, so that after 20 years, are we prepared for the disaster? Are we prepared for another tsunami like that? Have we built disaster resilient infrastructure as far as Indian coasts are concerned or Indian islands are concerned? So that was the reason that a question in mains was there as far as tsunami is concerned. Okay, so if we see this particular earthquake, the Kamchatka earthquake, the interesting part was there was not a single loss of life in such a high magnitude earthquake. This is quite high magnitude. The How much is the highest earthquake that we have recorded or have seen so far? Does anybody know which earthquake is considered as the deadliest earthquake that has occurred or which has the highest magnitude? The Chilean earthquake of 1960 was of 9.5 magnitude, and that is the highest magnitude earthquake that we have recorded. And this particular earthquake is very very the magnitude of this particular earthquake is very very close to it. Okay, 8.8 magnitude earthquake. Imagine if occurs in northern India where population density is huge. What kind of scenario will emerge? What kind of disaster it will become? We will not be able to imagine as well. But in Kamchatka, there was zero death. What was the reason for that? Disaster resilient infrastructure. They were prepared for this. Okay, someone might say that the population density is significantly less in Kamchatka Peninsula, but there are big cities as far as this particular region is concerned. There is Sakhalin Island, there is Kuril Island, there is in this particular region in near Kamchatka Peninsula, there are lots of major cities where population density is huge. Otherwise, in Far East Russia, the population density is comparatively less. But that is not the only reason. Despite the 8.8 magnitude earthquake, hardly, and they have prepared this building during the Soviet era. This is not a new construction. They have built these buildings, disaster resilient buildings, during the time of 1960s, 70s, 80s. So they knew that this particular region, the Circum-Pacific belt, receives huge amount of earthquake. So you can see the disaster resilient infrastructure in Japan as well, in Russia as well, and in the parts of South Korea and China as well. Okay, there is lot of disaster resilient infrastructure. But if we see the earthquake of 2011, which is the second deadliest earthquake, which was of around 9.3 magnitude, 9.3 or 9.1 magnitude earthquake was there in 2011 in Japan, in which is also known as Tohoku earthquake. This led to nuclear disaster. This earthquake led to Fukushima disaster. You might have heard about Fukushima disaster. And after that, after Fukushima disaster, near that particular island in Hokkaido only, there is a city known as Sendai. There are two cities, two Sendais in Japan. So in one of the Sendai framework was signed, which was related to disaster risk reduction. And this is for the period of from 2015 to 2030. And under this, we need to establish disaster resilient infrastructure. So each and every infrastructure that is going to be built after that should follow the principles that were agreed in Sendai framework. Okay, but in majority of the countries, it is not followed. But in these countries which are vulnerable, Sendai framework are followed, which is the reason for the less number of deaths or less or zero casualty as far as Kamchatka Peninsula is concerned. Along with that, the preparedness was there related to early warning system. So earthquake early warning system was there, was at place. People were made, people themselves took precautions. There was a very viral video as far as the earthquake of Russia is concerned. That one woman came out of the salon and she sat on the bench. She was not basically mm, afraid of the earthquake because she knew, and most of the people there knew that their infrastructure is disaster resilient. Their infrastructure is earthquake resilient. So they had such level of confidence as far as earthquake is concerned of this particular Kamchatka Peninsula. And multiple shock waves occurred after this Kamchatka Peninsula earthquake. And after that, there was tsunami also in this particular region. So here you can see that there is a microplate known as Okhotsk microplate. There is Sea of Okhotsk here. This is Sea of Okhotsk. So this microplate is named after the Sea of Okhotsk microplate. And here there is an interaction of Pacific plate, Okhotsk plate, and Eurasian plate. Eurasian plate is a continental plate. So because of the interaction, the convergent boundary interaction between these plates, there was earthquake in this particular Kamchatka Peninsula region, which triggered the tsunami in and around the Kuril Island and Sakhalin Island. And both Kuril Island and Sakhalin Island, try to locate this in your map. Kuril Island. Kuril Island is a disputed island between Japan and Russia. So Kuril Island as well as Sakhalin Island, they were basically prepared for the tsunami that happened because of this earthquake. Okay, they basically evacuated their people from that particular region, from those particular islands, uh, 200 meter, 300-meter away from the coastal region. Why? Because, sorry, 2 to 3 kilometers away from the coastal region. Why? Because 5-meter high waves generated in the earthquake that was there, in the tsunami that was there, as far as uh, Sakhalin Island, particularly Sakhalin Island is concerned. But that also did not impact the population of that particular area or the buildings of that particular area. Why? Because they had built the barriers in this particular region. Prior to they have built such nature barriers, such nature retention walls, which will not impact uh, the coast of the Sakhalin Island because of tsunami. So that was the nature of preparation as far as Kamchatka is concerned. Similar nature earthquake occurred in Myanmar. This occurred in around 3rd April of 2nd April, as far as no, sorry, 28th of March, I guess. Okay, yeah, 28th, 27th of March. This earthquake occurred. Yes, yes, yes. It is near Vladivostok. Vladivostok is in the far east Russia only. So it is Vladivostok is somewhere here, and this is Kamchatka Peninsula. Here, earthquake occurred. Okay, in Far East Russia only. So this is the earthquake of Kamchatka. But if we where zero casualty was there, and hardly any destruction of property was there. But if we see the Myanmar earthquake, this was the deadliest earthquake of 2025 because around 5,000 people lost their life. More than 5,000 people lost their life. As far as Myanmar earthquake is concerned, the epicenter of Myanmar earthquake was in Sagaing Fault. Okay, this term might come in prelims as well. So in Sagaing Fault, the epicenter was there, and here basically lot of death happened. In Afghanistan, there was a 6.1 magnitude earthquake. Here also around 3,000 people died. As per WHO sources, the the casualty that was reported because of this particular Afghanistan earthquake was 3,000, and in Myanmar it was 5,000. Why such nature destruction happened? If you see the images of these earthquakes, They were not of high magnitude. This was the another ripple that occurred after the 6.1 magnitude earthquake, the 6.2 magnitude earthquake in aftershocks of basically the earthquake. So this was the nature of destruction in Myanmar. This was the nature of destruction. We also launched Operation Brahma as far as Myanmar earthquake is concerned. Why this occurred? This happened because of the lack of disaster resilient infrastructure at place, lack of early warning system at place. Okay. If we have earlier, we used to consider that uh, the intensity of earthquake is determined by the magnitude of earthquake. Okay. Or both are co-linked, interlinked. But here we saw that 8.8 magnitude earthquake didn't cause any casualty, whereas 6.1 magnitude earthquake caused multiple casualties. More than 3,000 people died, 5,000 people died because of 7.7 magnitude earthquake. And if we see what is the difference between uh, 6 magnitude and 7 magnitude, or 7 to 8 magnitude, then 7 magnitude earthquake is 32 times more powerful than 6 magnitude earthquake. 8 magnitude earthquake is 32 into 32 times more powerful than 6 magnitude earthquake, around 1000 times more powerful than 6 magnitude earthquake. Still, it didn't cause much loss of life as far as Kamchatka Peninsula is concerned, because of disaster resilient infrastructure, because of preparedness as far as early warning system is concerned. Uh, that is what is required as far as uh, different types of disasters are concerned. We can do hazard mapping, we can prepare early warning system, we can make people aware as far as different types of disasters are concerned. For example, during the time period of 2004 tsunami, there was loss of life of around, loss of life of around 2,28,000 people. Imagine the nature of disaster because of tsunami that originated in Sunda Strait. Post that, we started thinking about the disaster management, and Hyogo framework was signed. You might have read about Hyogo framework. Okay. And after the Fukushima disaster, we signed the Sendai framework. We earlier saw this Sendai framework. So this is the nature of disaster. This is the nature of disaster as far as earthquake is concerned, and it is basically measured through moment magnitude scale. Sorry, moment magnitude scale, that is MMS. Uh, Usually we say that Richter scale is the parameter as far as consideration of magnitude is concerned. But nowadays, moment magnitude scale is considered, which has a formula of this: rigidity into area into slip. Rigidity of the rock determines the nature of the earthquake. Area on which it is happening, for example, how much far it is from the particular epicenter, and how much earth slip has happened, how much earth has moved, that determines the magnitude of the earthquake. So this is moment magnitude scale. But what determines the intensity of earthquake? You might have heard about Mercalli scale. So this is MMI, modified Mercalli intensity scale, and it is basically Am I audible? Just tell me. There is a slight disruption. सूरज एक बार होस्ट बनाना. There is slight disruption as far as this particular. Am I audible? Okay, okay, okay. So where were we? So we were discussing about this. Sorry. So we were discussing about uh, Mercalli scale. Okay, modified Mercalli intensity scale. So intensity is basically measured by the Mercalli scale, and here we can see that there are basically 12 parameters as far as scale is concerned. This scale is of 12 parameters, whereas the magnitude or Richter scale is of 10 parameters. So, or 10 numbers are there. Here, 12 numbers are there, and it increases towards the end. That is violent, extreme, and extreme is categorized under 10, 11, and 12 Mercalli scale. Here you can see that if there is total damage or waves can reach waves can be seen on ground surfaces, line of sight and level distorted, and objects are basically thrown upward into the air, then that will be the extreme scenario. The Afghanistan earthquake was of 10 Mercalli scale, where some well-built wooden structure got destroyed, most masonry and frame structures destroyed, with foundations and rail got bent. The Myanmar earthquake was of 12 intensity. So here there was a total damage as far as Sagaing fault earthquake was concerned in Myanmar. And this led to deaths in Thailand as well. In Bangkok also lots of people died. But comparatively, the death toll was high in Myanmar as compared to Thailand, because in Thailand there are disaster resilient infrastructures. You might have seen the swinging building because of the earthquake in Bangkok. It didn't fall. Why? Because it was a disaster resilient infrastructure, right? So after the earthquake, there was tsunami, but not in Myanmar. The tsunami was there as far as the Russian part was concerned. So this we have already seen. The tsunami that occurred in Kamchatka Peninsula, and the evacuation drive that happened in Japan. The warnings were issued in Alaska and Hawaii as far as tsunami is concerned. So that was there as far as this particular region is concerned. This particular the circum-Pacific belt is concerned. But Kamchatka Peninsula tsunami or Kamchatka tsunami is a case study. Okay, and this is about preparedness. This case study is what we need to write as far as uh, the means answer is concerned. That why there are no casualties in Kamchatka Peninsula, whereas there are high casualty in comparatively low magnitude earthquake because of the difference in preparedness, because of the difference in the infrastructure, the nature of infrastructure. This can be our argument along with the case study. So this is what I am. I think that you should prepare this particular topic in this manner. Along with this, we write a few terms like we use few terms like the different types of fault. For example, you might have heard about the 2022 Turkey earthquake. 2022 or 2023, it happened in 2022 only, I guess. Okay, yeah. So this here also around 50,000 people died. 50,000 people lost their life in Turkey. One of the most devastating earthquake. It happened because of the not because of convergent boundary. It happened in a region where there was transform boundary. Okay, it was a shallow focus earthquake, and it happened at the strike slip fault. So there are different types of fault. When the plate folds, there is creation of basically After folding, there is creation of cracks. Okay, you might have read about anticline, syncline, recumbent fold, over nappy formation like this. Okay, overturn fold. So because of this folding, after that there is creation of faulting, and there can be different types of faults like normal fault, reverse fault. Similarly, strike slip fault can be another type. So that earthquake occurred because of strike slip fault. This is what is required. This is linked to the basics of geography. Not needed here because that earthquake occurred in 2022, but you should know about different types of faults that are there as far as this nature of earthquake is concerned. And here we saw the different scales. We saw the difference in the earthquake that was there as far as this particular topic is concerned. You might have read about earthquake. You might have read about P waves, S waves. The questions as far as prelims is concerned, questions are from P waves, S waves. Okay, mostly in prelims, or different types of seismic waves. Love wave, Rayleigh wave question can also be there. So different types of seismic waves you need to study, different types of shadow zone you need to see. For example, P wave shadow zone is comparatively smaller than the S wave shadow zone. This you need to remember as far as prelims is concerned, which is a static area. As far as earthquake related questions in prelims only is concerned, there can be questions related to different places that were in news where earthquake occurred. For example, Kamchatka Peninsula, you need to see holistically. Sakhalin Island, Kuril Island, Sagaing Fault, Sagaing region, then Thailand, Myanmar region. This you need to see as far as this particular area is concerned. Okay, and in mains, you need to prepare your argument from disaster point of view, from preparedness point of view, from infrastructure resilience point of view. Okay, and here you can use few case studies like this. Kamchatka is a prominent case study that such a high magnitude earthquake, one of the highest magnitude earthquake, 8.8 magnitude earthquake, caused zero casualty. Okay, so this is what is required as far as different topic is concerned. Indian monsoon and earthquake is concerned. So, is there any doubt related to earthquake? Yes. Is there any doubt? Then we can conclude the session. Or are there any questions you want to ask related to earthquake or related to uh, monsoon? Any question you want to ask? Because this is how we need to prepare it. This is how we need to see the different news articles. If you read these news articles deeply, then you can see that all these news articles, different news articles can be combined, and a holistic picture can be developed. Okay, because you might be reading newspapers as well, you might be reading current affairs materials as well. That is that that is the bare minimum that you need to do. But then you need to link it. You need to think where to use this data as far as the current affairs data is concerned. You need to prepare the case studies, you need to prepare the examples, because examples and case studies can enrich your answer. Example and preparation of examples and case studies will help you in prelims as well, because now again the questions are coming from geography and environment section, right? So you need to prepare all this aspect. So on this note, we can end the session. Yeah, and we'll meet again. Today there was slight disruption as far as uh, the class was concerned towards the end. Otherwise, yes, okay, John. So we'll meet again for the geography current affairs. Okay. सुबह ज्वाइन कर देना मीटिंग। और कल 10:30 बजे रख देना क्लास। ठीक है, ठीक। हाँ, सवेरे। है ना, ये जो साइंस एंड टेक की क्लास है वो 10:30 बजे लगा देना। ओके, ओके।